Am I back? I think I'm back. I think we're here again, everybody. It is 8 o'clock on the 7th of May 2025. It's a Wednesday. Hello everyone. Hello Louis. Hello Apollonia. No Fernicar yet? Maybe he's typing. Oh wait, it's before the thing. It's above there. So anyway, hello everybody. Thank you all for joining. What are we looking at? Do you know what? The music's really loud for me tonight. What the hell's going on? Let's turn it down on my end, which is going to make things interesting. Hello everyone. Let me know if the audio is coming through loud and clear. We've got a little bit of a twist for you tonight. So, if you're watching live or you're watching later, there is a Discord link in the description. Hello MC Twig and DJ Berries. Glad you could join us. So we are following on with the Sharona development. We're now at version 3 and I think it's actually ready to be sort of more robustly tested. That means throwing different poses at it to see how it performs. And in order to do that, we're actually looking at a different computer for once. Isn't that interesting? We're not looking at the main machine, and I will be swapping it back to the main machine in a little bit. But for now, I want to show you, because I keep saying, oh, it's on the other machine, it's on the other machine. So that's what I mean by cloning. When I say we're going to poke the clone, we're going to poke my clone. So that would be a different machine, which is using a bunch of AIs to do work. You might have noticed. Hello, Dragon. Welcome, welcome. We're just taking a look at the fruits of labour. So obviously you all know that I have multiple machines that are all running at the same time. Hello, Fernicar Battle Cruiser operational. What's up, guys? Glad you could all join in. So it goes like this. This is a completely different machine. Okay. Now, I've got my smooth pan right here. Smooth pan shorts. We're going to be taking a look at the repo in a minute. Because I've done a load of work on it. So this is my laptop's default Acer background. I'm standing on the Acer logo. I just wanted to show you, like, this is a 4 gigabyte laptop. Let me just show you that. I'm going to show you what we're dealing with here. So we have 1 gigabyte SSD, 4 gigabyte graphics card, 16 gigabyte RAM, and an i7-1255U. 1.7 gigahertz. Alright. So this is by no means the mothership. This is the average laptop. Not even a gaming laptop. Average laptop. It's got NVIDIA, but this is probably, I think it's actually a 2050. Does it say anywhere? Multiple GPUs installed. Anyway. I think it's a 2050, 4 gigabytes. Now, we're going to go over a bunch of the other different versions. We're going to install them on the mothership in a bit. But for now, what I want to do is I want to show you, because like I said, we never get to go over the vibe coding side. So we're going to start. Average, because it has AVX2. I don't know. Where can I find that out, mate? Where can we find that out and see? Does it say that here somewhere? I think it just says virtualization yes, or something silly. But it's Windows 11. It's average. I'd call it average. it's one of the reasons I got it, because I needed like a mid-tier PC. So it's a laptop, it's only got 16 gigs. Yeah, it's an i7, but it's a 12 series. It's not the latest and greatest. I think it's like a year out maybe. And like I said, the graphics card is only a 4 gigabytes. Oh, I think I leant into my microphone. Okay, I'm back. So anyway, let's move on. So what I've got here is I've got a system which uses config. So let's go into VS Code. It's the easiest place to start, right? So obviously this is my project, and what it does, so you're all on the same page, my live streams. In fact, let's just have a little story time, okay? So we're live streaming right now, okay? This live stream is typically between 2 and 5 hours long. On average, they average about 4 hours. We've had some which have been 7 hours long. This is longer than Whisper can actually do, so you have to come up with systems to break it up into batches, which we've done. It's pretty easy to segment video and do a chain of, that's easy, right? But Whisper doesn't really describe everything that's going on. It's only what's being said. So I'm pretty good at saying everything I need to say, but sometimes I'll say, look at that, and there's no context, right? And so what we're doing at the moment is we're building our own systems for this, but at the moment I'm using a system for the bit in the middle. So essentially I give my URL for the live stream to a website, and then they do LLM stuff for us in the cloud with Vision. They actually watch the video and then create highlights for you, right? You specify, you've got parameters, right? But ultimately you get back a bunch of 1920 by 1080 like landscape video, okay? Like this. No, wait, that's output. Do I have a test input? Like this. Just like what you're watching right now. Yeah? So, and the idea is that when I was editing, what I found was all I needed to do was go start at the left edge and then pan to the middle for, you know, and then pan to the end and then hold it at the right side, okay? Because obviously you have to go from horizontal to a vertical format. So I'm just sort of explaining the challenge, you know what I mean? It's pretty simple. Pip install CPU feature, and then if CPU feature, let's try it, you hacker. Hacker. Why not? Take it for a spin, and then it like bricks my computer. Vertical Y. Oh no! Apparently I need Visual C++ 14. This is like a brand new computer. I haven't got that. Anyway, like I was saying. So I had this problem, and the problem is I've got like 600, 800 hours of footage, and I need to find the highlights that are only 30 seconds to a minute-ish long. And once I've done that, which is a big task as it is, so you know, you want to be able to automate that reliably, and I think I've got that down. There's a paid service that does it, and I'm building my own scripted solution, you know what I mean? And obviously I can upload it to GitHub and explain how to use it and all that good stuff. But at the moment what I've got is like, I've got all the pieces, but not the vision part in the middle. I was using describe anything module in video mode just recently, but I haven't cracked that nut yet. So I've got a custom YouTube download tool which will put it into segments for you, right? So you choose what you want the segments to be. It downloads it, done, right? So we've got the bit that pulls the YouTube live down, and apparently it can even do a mode where it records a live stream. So like I could be running it now. This is the funny thing. Once the system is there, I could set it to monitor the live stream while we're live, record it, every 5 minutes, whatever, it will segment off and push it to the vision agent, right? The vision agent is the bit I'm working on, which is proving harder to pull off. I can't remember what it is that it was, but anyway, so I'm going to show you a project I've used to try and hammer those edges, okay? Get better at CUDA, right? So I made up a little project, this. Basically, it's the other end, isn't it? You know, like, oh, okay, so we've got our vision, we've chopped up our highlights, we've got our highlights. Now you've got like 100 highlights, because think about it, it could be, if you're talking about going from hours long form to vertical shorts, you know what I mean? So you're going to have a lot of them, you know, if you get it right, which I think we have. Now, I'll admit, my editing for the shorts is done in a way to try and make you go and click on the link to watch the live. I'll admit that, right? That's by design. So it's kind of like you're looking through a letterbox that's just moving from left to right across as something interesting is happening. So you're kind of blinkered because it's, you know, it's vertical, but it's just a pan of the, anyway, whatever. But what it did was it gave us a programmatic way of editing. And that can be passed to an agent, and then the agent can do that part too. So we could make it more intelligent. But I wanted to show you the process, because I've done it all on this machine. So I can show you the process from start to finish, right? And I'm really happy with the performance of this. Let me just see, do I have a website? This is risky. Oh, okay, yeah, this is fine. Okay, so bunch of new repos which we're going to be talking about for the next little while, all related to what we're talking about. So we've got pan vertical CLI, that is the best one. It's stable. It's got the GPU acceleration with QDNN and CUDA tools. So it is as fast as it's going to get without getting experimental. Okay. There's also a version of pan vertical in UV. So I wanted to see how good Claude was at building the entire thing out in a UV pip package manager style. So we've got the exact same project. I mean, I'll admit, this one's probably a bit, maybe it might be a little more updated. Actually, look, 16 hours, 16 hours. They should be the same, actually. So I think what I've done is I've taken this, and then I've cloned it, converted the whole sort of, because this is the thing. I can write a Python script, right? But then how does the user run it? Usually a virtual environment, right? But people get tripping up. They're tripping up trying, oh, did I activate it? Oh, I don't know if I've activated the environment. So you give them a batch file, right? And the batch file installs from the requirements, and you've got all your packages in there. So it's straightforward. Everyone knows how to do that, but UV does it all for you, you know? And what I found was, yeah, but when you start getting advanced with it, it might get a bit tricky, and Claude isn't actually as good as he is with the old methods because it's relatively new. UV is relatively new. Now I found a way of getting around that, which I will show, and that's really cool because if there's ever like a project that hit tomorrow and the AI doesn't know it, this method will allow you to work with that project. Okay. Sorry, and the last one is the unstable version, right? So the unstable version, I decided to take this CLI forked it, made a completely new repo. This is super experimental, guys. Like, I've got another hot version on this machine right now that we're looking at, and quite frankly, I wouldn't be surprised if it's a complete mess because I was shooting for the moon on this one, guys. Like, let me have a look at the README. It's ambitious. So we've got like a pipeline here which can scale with the amount of VRAM and go for like high batch. So it's built for speed, and it has one job: turn my horizontal video into a vertical. Because I thought, let's say I had $20 and 24 hours, and I had a tool, like I've got 100 shorts I need to, and all I'm doing is opening up the short and going marker left, marker center, marker right. Even if you control paste the markers, you've still got to go through every file and put it in the template, you know, with the overlay. Say you're using Premiere, Vegas, whatever it is you use to edit, right? DaVinci. The point I'm trying to make is you're going to be sat there for an hour, at least, maybe two. And I was like, do you know what? I'd rather spend an hour in vibe code or more. I'd rather spend all night in vibe code actually with 20 bucks and automate just that. So this tool isn't supposed to be like the best editing thing ever. It's literally, I thought it's only a day, less, a couple hours, and I can have a tool that will just do that for me, that job, just that job. And that's what we've done. It transforms landscape videos into portrait. That's it. With a programmable pan, okay? So there's 3 marker points. Let me skip down to the config file here and you'll be able to see it's still going on about performance. There we go, right. So you have, oh yeah, and also it batch processes the whole folder. So you literally say, see this folder full of videos, make them vertical. Off it goes. Now it's fixed in 1280p at the moment. 1280p? What the hell? 720p. It's fixed in 720p right now, so it converts from 1280, 720 to 720, 1280. But I might do a future version of it which, like, you know, gives you more of those sorts of options. But feel free to fork it and do whatever you want. Okay? The point is, at the moment, that's what it does. So if I give it 1080, it's going to scale it down. If I give it a weird image for the overlay, it's going to scale it down and crop it. So it's going to be consistent, right? Everything ends up being 720 by 1280, ultimately. Right? But what you can do is you can say, well, I want the mark point to be at a percentage. So it doesn't care what length the video is, it will figure it out. So 5%, 50%, 90%. So it's like, sort of holds a bit at the beginning, then it starts panning. At the midpoint, it's in the middle, and then at the end, it can do like a fast scroll. And so you can change the rate at which it's coming in and out, and the speed and everything like that with these, just by defining these percents. Left, center, right. Okay? That's what it does. So 5% in, it's left, so up to, you know, from the beginning to there, it holds it. Yeah? And then it will go from the left the line to the center line, 50, and so on. And like I say, because 1280p, 720p, when you put them together, it's like a cross that intersects. So then you have an overlay image. So if you put the file name in the templates folder, okay, you end up with a top and bottom where you can put a logo, some text, some artwork, a frame, whatever, you know, and then that just gets stamped over the top. If you don't use a background, it's black by default, okay. Yeah, right. So obviously you put the file name, .ping, shorts.ping is what I got, and that'll do that. But that's not where it ends, because like I said, this one was shooting for the moon. So we've actually got hardware acceleration for NVIDIA, Intel or none. We have a batch size, so you can scale it up with VRAM, and you have a percentage of GPU memory allocation. The final version I've got here, and I think the unstable version is the same, it's got multi-threading, so it uses a different CPU thread for input, overlaying, and output saving, which speeds it up a lot. And then it also uses CUPY, or CUPY, which is CUDA Python, right? So it's speeding all of that up, and then also it ditches NumPy, or it runs NumPy with CUPY, so we're accelerating NumPy as well. So I'm basically what I wanted to do was just mess around and see if we could pull it off. We actually managed to pull off quite a bit with the unstable version. I say unstable because it's like, I just like said, hey Claude, you know, what can we do? And in the end, like I said, it detects the GPU, so it won't even use this pipeline if you don't have more than 16 gigabytes, but obviously you can just go into the config and change that to whatever you want if you want to play with it. Let's see, keep going. GPU allocation, there's also a pipeline queue size. I'm just trying to see here, is there anything else? There's so much troubleshooting. Right, so no pipeline architecture issues, no acknowledgements. Should just say Claude. Here we go. So anyway, the speed, right? If you were to run this sort of job on a particular video, you're going to get 10 to 15 FPS on a 4GB laptop GPU, right? Now, with acceleration, we were able to get that up to 70, okay? Which is not bad, right? Now, if you take away the overlay, it's 125. That was the fastest I could get it to go. But as soon as you start overlaying like a logo frame to every image, it does slow it down. We did all kinds of stuff, okay? But yeah, we ended up on a 24 gig because you can increase the batch size. Because remember, I've been optimizing it for 4 gigabyte, but I've been putting in a bunch of features for the 24. So I'm hoping that what I can do is put this up, bring it down on the main line, and then see if we can't prove that, right? So I already have the baseline figures, right? I've managed to get on a 4 gigabyte. I've managed to go from 15 to between 60 and 80, depending on what the hijinks, okay? Because we did all, there's so much craziness going on here. Honestly, I've never even tried to do a lot of this stuff before. Because, so for example, you have to have CUDA toolkit, yeah? It has to be set up as a CUDA path environment variable, CUDA path, right? You've got to have that set up. You also need OpenC. Oh yeah, you remember my triple redundancy website? This is falling back from Koopy to OpenCV CUDA, and then again to CPU. So the tool actually, it's got, like I say, it's triple redundant. It will still work. It just gets slower. Unaccelerated, you're probably, for the test video I'm using, probably looking at like it's about 300 or 400 seconds, I think. Okay, so here we are. So CPU no overlay. This chart's all messed up. It's hard to read now. But yeah, CPU no overlay, we got 125. CUDA no overlay was still 125, because like I said, the CPU mode was also optimized. So it's not like we just turned on CUDA. Normally what happens is I just switch out PyTorch for PyTorch CUDA and hope for the best. But what we did this time was we actually went a little bit further than we normally go, and we were like, OpenCV, we can accelerate that. NumPy, we can accelerate that. And then like you have to go through and change a whole bunch of stuff. But yeah, ultimately you're looking at 280% on there. With the overlay, I could get 200 and then 88, so you can see the numbers. So, oh yeah, direct, what is it? Zero copy data paths. And we've got, we've set up zero copy between FFmpeg and Koopy or OpenCV. That was huge. I was like, this last bit took forever. And in fact, it might not even work. Because when I tried to run it, it says your system isn't good enough, right? So I haven't actually tested it. This could be broken because it's just too advanced. Like, what's it even trying to do? What's that? That's not a CPU feature. Hang on. There. Test completed. Look, system does not meet requirements for FFmpeg direct integration. So we're not, as far as I can tell, he rewrote FFmpeg just for this. Yeah, so we're not actually running FFmpeg anymore, even though it is there as a fallback. We actually have rewritten it into this now. So I was like, let's see how far we can go, right? We're probably spent $20 and 6 billion tokens. No, billion. Okay. One day. Let's see. So, oh yeah, we also vectorized the operations, so the loops are all gone as well. Yeah, here we go, look. Vectorized operation replaces loops with high-performance NumPy arrays, and then array operations, and then pre-computed lookup tables, stores common calculations for faster access, optimized alpha blending, 3 times faster transparency with vectorized calculation, smart memory management, reuses arrays and minimizes allocation, broadcasting technique, eliminates per channel loop for faster image processing. To be honest, right, all of this stuff is like black magic to me. I understand what it is because I've read about it, but I've never used it. And as far as I can tell, it's doing it. So yeah, parallel operations on the GPU. That's the batching. Oh well, process multiple simultaneously. Yeah. So yeah, if you're running with more than 12 gig, it will automatically detect and enable all this. We've got algorithmic optimizations. Here we go. FFmpeg Direct C API. Zero copy data paths, I mentioned that. Hardware accelerated decoding and encode, so NVENC and NVDEC. And apparently Intel QSV, which I can't test. I don't think I've got it. But yeah, anyway, like I said, this is like a test bed to see how far we can take it. You know what I mean? Okay. And like I said, it's tested. See here, this is a real world config. I can't make it bigger, goddamn it. Right, so downloads, that's where the clips are. I downloaded them and put them all in a folder. Output, that's where it's going to save them. And then mark point 2, 75, 85, and then shorts is the overlay done. Off you go. Now, obviously, this was done before all of the optimizations are made, so I don't have those. But it's like when you run a program without saying options. It just uses defaults if you don't say it. So you don't have to put in everything. But the full list of options currently is this. I think there might even be a couple more. But batch size is something I want to check out, because that might, well, you're sort of getting into the point of diminishing returns where speeding up actually doesn't double. It might only give a percentage, because you know we've already doubled, tripled, so it's like there's going to be diminishing returns at some point. Probably will hit the memory limit for the card. Trying to do like YouTube shorts. But yeah, there's one interesting thing about this repo which I want to show you guys real quick. So if I go into the, is it the CLI or the unstable? Let's go into the CLI version. So this is like the stable version, right? It hasn't got any of the experimental stuff. It just works and it does perform well. It goes fast, it runs on a 4 gig, good stuff. A great base if you want to make stuff like this. And what was it I wanted to show you? Yeah. So there's 2 documents which I'm trying to include in all of these repos, and this is really the most important thing. I'm going to be using these over and over and over and over again with my agents, because check this out. Okay, let's see. Is it which one do you look at first? Yeah, it's this one. So what I've done here is I've actually written a tutorial for how to set up CUDA path so that your virtual, because right, often what happens is you make your virtual environment and it doesn't actually know how to talk to CUDA. You know how we set up system environment variables for Comfy? This is kind of like the same thing, but you can do it either in the batch file or the PS1 script or the bash script. You can do it in the scripts in the VNV, or you can do it in line, which is what I'm electing to do, because then you don't have to change the VNV after it's been made. I think it's cleaner. But essentially you do have to have this set up on your system. So you go to the NVIDIA website, download the NVIDIA CUDA toolkit, you install it, and then from that path, well, first of all you have to do env CUDA. So I use PowerShell because it's easy. So we set up PowerShell to set up this CUDA path to where you installed it. I used 11.8 because it's got good backwards compatibility. And like I said, this is gold, man. Because we've had so much problems with speeding up things with CUDA, and the reality is it's not just PyTorch. There's so many of them out there, and once the LLM has got like this in its brain, it's like, oh, you want to use CUDA? And he starts telling you all of this extra stuff to do, and everything gets really, really fast. So I'm kind of like cracking this nut, because what you find is people make a GitHub, and they kind of like, they don't really give, because they're like, here it is, it works, and then they're working on something else. They don't have time to come in and do all of this stuff, which is completely fair and fine. I'm not making any criticism of anybody. I'm just saying it's kind of our job. If we want to do this, we have to do this. And if you give these 2 MD files to an LLM and say, hey, can we implement CUDA? He might turn around and say no. Sometimes there's nothing to accelerate, depends on what you're writing, but at least he can tell you that. And a lot of the time he'll say, yeah, we can make this 2 to 5 times faster if you have VRAM, like a GPU. So anyway, you download the thing, you set the path, done, easy. Okay, now see the virtual environment. This method is telling you to go in and edit the script and add these lines to the top of the script here. That's what it's telling you to do. Okay, but I would just pause on that. The important part is knowing how to get this part set up, because there are other ways of creating the there are other ways of setting this, which you don't have to edit the script for. Yeah, because I would hate to have to do that every time. It's kind of annoying. I'd probably write a script to do it. So like I said, I wrote this initially for myself when I was doing it on my laptop. New computer, I've probably only ever done it once on my main machine years ago, and then I forgot all about it. So I put this note up so I could do it easily on my laptop. Next one, this is even more interesting. Actually, I can zoom this in. Okay. So CUDA acceleration setup guide. Yeah. So as you can see, you need an NVIDIA GPU, you need the toolkit, right? And then you need the CUDA and library. This was the bit that was like another piece of the puzzle that I never ever do. So installation script, oh great, it's for UV. I'm going to have to rewrite it for you guys. I obviously made this one for the UV library. Anyway, I knew this would happen. Anyway, you create virtual environment, install the packages, set up the CUDA environment variables. That's the bit. You set up CUDA environment variables. So then your virtual environment can talk to CUDA and the toolkit and whatever other CUDA enabled packages you're running, right? So here we've got the explanation. So you go there and you download it, right? And when you've downloaded it, you've got to copy these driver files into your CUDA tools folder. So again, I'm using CUDA 11.8 for this. So again, if you want to use a different CUDA, make sure it matches the one that you did in the previous step. I haven't actually installed TensorRT yet. I don't doubt it gets even faster again. You see what I mean? But yeah, you do the DLLs, you do the CUDAs, you do the libs. So the DLLs, the H's and the libs into bin, include and lib x64. It's all very simple to follow. I went through it exactly as it says, and it works 100%. And then, like I said, suddenly you can use CuPy. And like I said, CuPy is awesome. So, like I said, instead of using CPU for OpenCV stuff, now you're using CuPy, which is CUDA accelerated, right? The other thing as well is, is it called, I think it might just be called AV or PyAV or QAV. I'm not sure, I can't remember. I'll have to check. But that gives you CUDA acceleration for NumPy. And the thing is, right, there are so many nodes that I've got that are running on CPU, NumPy or OpenCV. So many nodes, so many scripts I've written. And I've got to admit, guys, I just went, oh, it's got Torch and it was faster, so I called it a day. But I'll be real, I'm learning. And this is one thing I want to point out. A lot of people will say, oh, AI, none of you are learning anything. Dude, I never would have learned this level of information to do with CUDA optimization. Never. Because it's so hard to find all the bits, or which model version goes with this. And when the thing can say, oh, I'm going to show you a working version, I've now built it 50 times. You notice things. Do you know what I mean? Even if you didn't completely had no idea what you were looking at, you notice patterns. You go, oh, okay. Now I figured out I need this to make that work, and I got and you start. And so, like I said, this is like a learning acceleration tool, right? In my opinion, I think it's the complete opposite. I think you're actually just learning at a rate you've never learned at. I wonder if people will actually start burning out from it. I don't know. Anyway, so this is my point. We ended up with a crazy tool, and what I want to do over the next however long until the hour ends is show you how we actually got here, because we never get to look at this part of things. You know, it's all very well and good me showing you. I mean, hey, should we show the thing? Does it even work? Remember, we're on a CPU right now. So if I just do... I'm going to do the original OpenCV implementation because I don't think I can... Ah, this one's broken. Good stuff, mate. Great. Let me try it again. Yeah, this one's cooked. Config AV. Yeah, it's AV. Yeah, it's AV. So like I said, this is like the dev box. And what I do is I upload versions that work to the GitHub. So if you download them, they should work. The unstable, I can't be sure. But yeah, when we jump over to the main machine, I will show the thing working. But for now, let's just take a look at this. All right? So forget the code for a minute. Let's just put a requirements behind me. That'll do. All right. So we're not looking at that job. We're going to go all history and let's go back down. So let's see. My project's now using CUDA. We'll create a new install. Create a new CUDA. Can CUDA help? We should total up the cost because this one was a big experiment, right? When I run main pi, I get an error. Non-existent. Wait. CLI tool using Vision to watch and describe a video. That's top secret. That's not that one. That only cost me 50 cents though. My new landscape vertical format video automation tool is completed and works great. Here we go. So often I come to it with a working script, which is what's happened in this case. All right. So we take a look at this, we go all the way to the top. Is that actually readable on the screen? Because I want to know, and I want to, you know, change the view and stuff if it's not. So I'm going to give you guys a minute to respond. And then I'll try and see if I can actually find out where you change the text. So zoom in, yeah. You got what you got to do. Not Control plus equals. Control and equals. How's that looking? Better? I've zoomed in a whole bunch. It's all good. We've got time. It's a bit blurry, is it? Let's go one more time. How about that? That's about as big as it gets, guys. All right. So, there's the prompt. Now, obviously, I've come in here with a working prototype. It wouldn't have been pretty and it wouldn't have had the overlay. It literally would have been like 3 points, pan from left to center to end with 0, 50, 100%. You know, kind of extremely basic panning script, okay? Thank you, Kirk. Appreciate it. So, my new landscape to vertical format video automation tool is completed and works great. Everything is working with regard to the panning. However, I appear to have a new problem. The audio for the video is missing. As we have the source video, we can simply add the original audio to the finished file at the end. So basically, my original script didn't have any audio, right? So I said, well, maybe we can make the audio be saved with the panning process. So I'm trying to see, can we do it at the end or can we do it as part of the process, right? Which one do you think? Okay. This one cost $1.29. That's 2 bananas. Can we make that smaller? There we go. So he's like, okay, cool, we'll do that, right? With OpenCV. OpenCV doesn't do audio. Right. Blah, 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 blah. Yeah. So add audio after processing. Or use FFmpeg throughout, which ended up being one of the sort of experimental pathways. Okay. So we're using FFmpeg Python. So it's like, again, How are you going to learn that there even is an FFmpeg Python? You might know what FFmpeg is, but did you know there was an FFmpeg Python? There's actually another one. There's 3 of them actually. And you can have all 3 and have like fallback, use them as fallbacks. Anyway, let's keep going. FFmpeg Python, he's trying to do it, he's editing the file, we do the first test. Python, video panner, config, test JSON, verbose. Right, now, a couple of things. Asking for a verbose option is nice, because you'll get really good logging when you're debugging your tool. And also, this is something which I've been doing lately. If the user doesn't pass anything, just runs the script, it doesn't crash. You set defaults for every parameter so that within even an example input file in a folder somewhere, so that if the user downloads the repo and runs the script, it will run without any parameters and it will just use defaults. It's nice because it means you can download something and see it working before you go messing about finding all of the stuff you need to do 28 parameters. And once you've got that working, you create an --config path to test.json, right? And so the JSON file will contain all the parameters in JSON format, pre-filled with defaults. Why do you do this? Because then you can have preset system. So the user can go ahead and have an LLM create the JSONs for you. And then now your script is a tool. Okay? We've been working on this for so long, it's like really nice to be able to actually crack it open and just make all kinds of different things. So anyway, all of this was about adding the audio. So now I said update the README, include the dependencies. That's an interesting way of putting it. Yeah. I want to have an explanation. Right, the dependencies are listed in the requirements.txt, but I want him to put an explanation in the README for users that download the tool. Okay, so now he's done it. He crashes a couple times. There we go. OpenCV Python. There's another one. You know, so it's like there's so many different libraries out there for different things. Like I would never have known. I would have just been using the other library that we normally use. So video panner config test JSON, right? I eventually wrapped this into a batch file that runs the virtual environment, okay? So you're not just running this, because we eventually have a virtual environment, and yeah. You're running a batch file which contains this, and then you'd edit the batch file. So let me show you. So for example, I have shorts.json, which contains a path to where they are, path to where they need to be saved, the marker points, and the overlay file. The overlay file is in the templates folder, nice and simple. And then you have a shorts91.bat, which simply contains the name of the config. Obviously, we activate our VNV here in the batch, so you don't have to worry about that. I do a check first frame as well, which is nice. Because what it does is when you actually run the script, it gives you a debug and you get just the first frame. And you can see here, oh, that's not right. There's no overlay. Or is it just zoomed out? Hold up. Huh? Wait a minute. There we go. Okay, so it looks like I've run this one a bunch of times. So I'm going to have to figure that out. But yeah, basically that one has it. Oh, I remember now. This one is widescreen. This one has the overlay. And this one doesn't have the overlay. So it's giving me all of them for some reason. That's okay. Alright, cool. So, like I was saying. Oh, so we keep going. So then I said, currently if an overlay is too large is added, we're not handling this occurrence. We should scale the image down to the expected output size of 720 1080 vertical aspect ratio. We can preserve the overlay template image aspect ratio, then center crop if there are any extra pixels, ensuring the final image matching. I meant is output video dimensions. So off he goes, he does that, he does all of that. Let's just keep going. The test passed, by the way. If you see me paste an error, something failed. So all the way so far, it's just been win, win, win. So my new landscape to vertical. Right, now I got to find that one again. Yeah, it's this one next. So another 2 bananas. We're up to 4 bananas, guys. I need to put like an overlay up on the screen so you can see it, but this time I've said since we introduced the image overlay option, it's slowed by 300%. Is there any way to improve the logic but preserving the features of README? So in other words, the slowdown was huge from having that, you know, having an overlay. It was a huge slowdown, guys. And so I wanted to find a better way. And so this is what we're investigating on this run here. Oh. So he reads the stuff and he says bottlenecks, right? Resize and center overlay function is called for every frame. Alpha blending operations computationally expensive. Creation of new arrays for each frame adds overhead. So in other words, what he's saying is, instead of setting a variable that's been set from the first one and then just using that over and over again, it's actually calculating it for every single frame of the video, which is kind of stupid. Okay, but you know, what are you going to do? So frame by frame, each frame is processed individually for multiple. So it was literally going frame, do the whole thing, frame, do the whole thing. So you can see how, like, when you get your vibe code, it's cool, it works, but it's probably an absolute pig if you looked at it and pulled apart how it was working. So these are the sorts of things I've been investigating with this test case. So his plan is to pre-process the overlay image once instead of for every frame. So that's going to be a huge optimization, right? So it's going to resize and center the overlay and then store the alpha as pre-computed arrays. And we actually managed to optimize that further later. Then we start using vectorization for NumPy, or with NumPy, right? If you wanted to ask me how the hell it does this, I would suggest downloading the code and having a look, because I actually couldn't. That's the reality. I've never done vectorization in Python until AI came along. I was very old-fashioned. And by that I mean like lots and lots of if statements, yeah? You can make your jokes. If this, if that, then else. Anyway. Optimize alpha blending, improve efficiency of alpha compositing operations, pre-compute alpha masks, consider parallelization, frames in batches, multi-processing, memory management, reuse arrays where possible instead of creating new ones. So this is all good stuff, all great efficiency stuff, right? So off he goes, and he says the most significant bottleneck is the overlay, which it is. It still is. It's still 50% of the time is the overlay. Resizing, but I guess it always will be, no matter how fast you go, I guess. I don't know. Anyway, so yeah, it doesn't need to do that every time, blah, blah, blah. So he goes on about it. I say, yeah, you go ahead, my man. We let him cook, and I'm like, somehow it got slower. Now, at this point, I want to point out, I'm putting a 1080p video in and getting a 720p video out. If I don't do the overlay, it's twice as fast. And I believe I was getting about 30 seconds and 60 seconds. So 60 without the overlay, 60 FPS and 30 FPS with the overlay. And if I did it with CPU, it was 15. So you're like not very fast, guys. 15 frames is all you could get. And I'm on a 4GB GPU for this because I wanted to be realistic about it. It's no good to be like, oh, I've got a 4090, everything's great. It's like, well, most people don't. So that's why we're doing this research here. So I told him it's 50% slower. So even though he did all these optimizations, it was actually slower, right? So he has a look at the bottlenecks again, and he finds a bunch of junk code. And so I let him fix it. Okay, that's the bottom line, is what happened. And I'm like, it's now even slower. Okay, so we're getting into like vibe code hell now. It was 200 seconds. Now it's 250. Sorry, then it went 250. Now it's 270. So it's actually getting slower, right? And what I didn't realize was the reason it was getting slower is because by building in all of this stuff, it was scaling with my hardware, which I don't have much of, and that was resulting in it actually like running with 0.7 of the memory, not 100%, stuff like that. Because, you know, I put in like a VRAM percent, and so obviously it was slower. Anyway, so look, yeah, it's 35% slower, Tech Johnson, because you are only using 0.7 now. But the point is, I wanted to like, you know, you're fired if you don't fix this, you know. So yeah, he runs the thing, and we go on to another thing. So we're now at $2.60. Let's see what happens in the next episode. $2.60. Here we go. Oh wait, no, it's the one before that. I think it's the one that says it's slowed down by 300%. Everything is working. No, that's the one we just read. So the next one is $1. So that puts us up to $4.60, which is, I don't know, the price of a cup of coffee at Costa, maybe, I don't know. How's inflation feeling over there? I don't know. Current output from Video Panner is a black screen, so yeah, lol. So we got a really good speed out of the last test. It was really good because it was just black screen. So I said, we need to fix this, and that cost me $1. Like I said, taking this just short of $5. So here we are. I need to examine test overlay JSON, so he reads it. And let me read the README, so he reads it. Let me read the test overlay again, so he reads that. Let me read the requirements, okay. Now I want to read the templates. There's just an image in there. Now let me read test. That's full of videos. He's like, I think I know what to do. He hasn't actually read the script at this point, which I thought was quite funny. Yeah, he hasn't actually read the script yet. So I've examined the script. Okay, fair enough, whatever. He said how the cropped section is positioned. Yeah, so in other words, he broke it. Cool. So in other words, we fixed that, okay? So let's just skip past this, because this wasn't like a big deal. He literally broke it. What's this? There we go, check first frame, which is nice. I can see it's been successfully processed without producing a black video. Debug output and save frames helped identify and fix. Source video mismatch. So basically, because of the fact the source was 1920 and it was going into 12, it blew itself up, blew its own brains out, I guess. Also, file paths. Right? Everything was all scuffed, so we had to unscuff it. So anyway. These are the things that he fixed. Frame bounds. And then it gives a check first frame option, which is nice because, like I said, you get that preview PNG just to make sure that a big job isn't a complete waste of time. Okay. We do the debug. And then I'm like, no, you can't use computer use because I don't ever let him do it. It's too expensive to let him use browser, you know? For some reason, it just costs loads. Black screen. So then we spend another $1, taking it up to $6, just under $6. And I'm like, literally, this is the experimental part. Now this bit makes it to the stable release of CLI, and then the UV was a conversion of that, right? But yeah, so here we go. We're going to do automatic GPU detection. Okay. Detects GPU and uses CUDA. Accelerated operations, frame cropping, resizing, alpha blending, all using GPU acceleration. This is important because before, if it didn't use Torch, it didn't get accelerated. Right? Graceful fallback. If CUDA isn't available or encounters errors, the system falls back to CPU processing. So yeah, 3 to 5 times faster. For a big job like this, where you've got 100 videos, it was amazing. And like I said, I've used this already. I think I might have. Hang on. What's it looking like? I don't even know. Hang on. Can I put it on 50 per page? How many of these have we got? These are all drafted. I haven't even scheduled them. So we're on page 2. Where's page 3? Page 3. Page 3. Ah, wait. These have come out. All right. Okay. So like 150, just under 150. And the thing is, I've still got more to upload. I haven't uploaded all of them yet. I'm getting there. Anyway. Get that one out of the way. So yeah, you know, because the thing is, it's always been a problem when you've got hundreds of hours of content. Do you know what I mean? And it's solved. The problem's solved, but the challenge was, how do you get hundreds of hours of content into clip form and then actually process that into something that can be uploaded and scheduled? Do you see what I mean? All of it will link back to the original stream, you see. So then there'll be just like every stream should have about 20 or 30 shorts ultimately, and also it schedules way ahead of time. So like over the summer months, it'll be queued up until Christmas pretty much. And then people say, oh, but like, oh, you know, won't it be irrelevant by the time it comes out? And I'm not really, because we're highlighting live streams that you can go back to. I don't think that many of the live streams are really dated. There's a lot of stuff in these shows, and if you're learning, it doesn't really matter which one you watch as well, as long as it's like relevant to what you're trying to learn. But anyway, like I say, let's get back to this. So is that it? Oh yeah, so I implemented the env bat. So we've got a batch file that creates the environment and installs the dependencies, and then we've got a start.env which you customize with your config, and then that way you know that it's running the virtual environment when you run the script, and then everything that we've installed, it's all working fine. Okay, we haven't got as far as all of the Kudan and CUDA tools stuff yet, so this is like simple, right? Okay, so that is it. Can CUDA help me? I'm surprised that I didn't write more than that. I could have sworn I wrote like a plan. Oh, there we go. CUDA, can CUDA help me? So next one is $2, taking us up to $8. And so I said, we're working with CUDA. I've installed CUDA Toolkit, added CUDA Path, VNV like we talked about earlier. So I'm right at this point, I'm adding these lines to my Activate PS1, but it was still reporting no CUDA. So I did the install and it didn't work. I was like, what? You told me what to do, and I did it and it didn't work. So he's then given me the CUDA Path fault. I was showing you that one as well, the CUDA Path MD, which basically shows everything about the CUDA and how to get the CUDA set up. So I obviously went away, I did that. It cost me $2, but then I have a guide to always getting it right. So I'm like, yeah, okay. Said that one. Right. Next big idea. Check it out. So at this point, we're at like version 3. We've already got it working. The CUDA acceleration is working with the CLI tool. And what I say to myself is, wouldn't it be cool if we could use UV, Package Manager, instead of all this pip nonsense and scuffed virtual environments? Wouldn't that be nice? And I said, I wonder what it looks like to use all the optimizations that we've used up to this point with that setup. So that's what this is. So you can see what I've written. We can create a new installation method for my project, give it your script, which you currently use requirements.txt. You should have both of those things if you've got a script you want to convert. To create a VNV, full instructions here, readme. So this is all the stuff that you should already have, with more detailed CUDA Path MD for instructions for CUDA acceleration. So all those files are in the repo. You know, you might not have that one, but you should have a README and the script and your requirements, I would have thought, if it's a Python script. So I said the plan is to create new install uv.bat and install uv.ps1 scripts, which will use UV to manage the virtual environment and packages. Okay. and there were missing requirements as well. Some strange thing, pip will install packages because they're kind of related by it automatically, but UV doesn't. So sometimes you'll be like, oh, this is missing, and then you add it to UV and it works. But it's just kind of ironic that the package manager actually misses packages that pip can get. It's just ironic. I guess it's the exception that breaks the rule, right? But anyway, so we had a couple of missing things. We missed that. We were missing some driver files. I still don't have CU Tensor. I never installed TensorRT, because the one thing I also do is the laptop runs on a really low bandwidth connection when I'm testing. Because again, I'm not trying to simulate being connected to the high-speed fiber. I want to know if my application still works on dial-up. Well, maybe not dial-up, but low-speed Wi-Fi. You get me? Because a lot of people will use a mobile phone connection and it ain't that fast, right? So you can't be thinking, oh, I'm going to just stream loads of data. It's just going to chug, yeah? So anyway, this is another thing I do with the test setup. Run install UV or install UV. Choose Y, create the environment, follow the instructions. It's actually really nice. I really like how UV is, how it's set up. It's super easy to use. It's very, you know what I mean? Very intuitive. Okay. So we set that up. It works. You can see the repo. It's up on the GitHub. So if we just go back real quick, you can see in my repos that we have the UV version right here. So UV version and CLI version should be roughly parallel. There might be some changes, but, you know, aside from the fact that one is using pip install and the other one is using UV, so it's still Python pip packages, but, you know, I just wanted to do it for fun. But now we're going to be getting into the unstable version, right? So this is like the part which gets interesting, because like I said, you'd be quite surprised to see what Claude can do when you actually give him a chance. I was like, I didn't even know you had it in you, mate. So video Panopy, yeah, so let's just go back down again. Video Panopy, where is it? No. Okay, so I'm going to skip past a lot of the UV build stuff because, yeah, project's now using CUDA, but we get a strange error or a strange warning, PowerShell warning. We can update the README to reflect the fact we've removed the alt. So this is the README for the UV installation. So if you're interested in that, just go ahead and download the UV version of this project and you can take it apart. And like I said, if you're an expert with the old system, what I've done is I've given you two repos that you can look at side by side and go, this is the one way of doing it, this is the other way of doing it. Hang on a sec. I got a knock on the door. Hold up. Good timing. It is actually coffee time, but I was unprepared. Yeah, my brother just needs to move my car, but we'll be back to it in just a few seconds. Yeah. You're a brave man. All right. Fine line that you're going to walk in. The Doritos spinning. Yeah. Hello everybody, welcome back. Like I said, it is coffee time, that part of the stream where I go and make coffee. I thank you all for your patience. Let's sit down. Alright, so where were we? The irony is... Oh, bloody hell. That sounded throaty. So, the irony is we're making images on the other machine. It would probably be more interesting to watch that. Sorry to be a tease. Okay, let's get back to it. Hello everyone. Welcome back. This is Scuffed Epoch. I'm Drift Johnson and we've just gone 9 o'clock. Tonight we're having a bit of a special look. I'm calling it Poking My Clone because I have all these different machines, they all have VS Code, they're all running these automated build this, build that, build this, and so it's like having 3 people, yeah, but we never get to see what that machine is doing. So I decided to take the last project from yesterday and just go through it because all the repos are up on GitHub. So with this stream it's kind of like a commentary track, I guess you could say. And I encourage people to fork my code. Okay, so here we go. We were just looking at strange warning, PowerShell red text, update the README. Right. Now I'm going back to optimizations. I'm saying currently we are using a 4GB VRAM GPU. How will running this on 24 affect speed? We can take advantage of the menu to increase the speed. Now this is a bit of a meme. I spelt it wrong. I wasn't. We can take advantage of the menu. I'm not sure what I was trying to say there. Okay, I'll be real. I was just typing fast. And anyway, $4.25 later. And this is going to get expensive as well because I decided to push it a bit. Right. Anyway, well, I say expensive by my standard, right? So this is the multi-threaded pipeline architecture. All right, now when I had it running on the 4 gig, it worked really nicely actually, but it didn't really give a speed gain because, you know, it's a low amount of memory. I feel that when I put it on the main computer, it's going to be much quicker. But anyway, so new pipeline architecture section. It's got a frame reader, a frame processor, and a frame writer. So it's using a different CPU thread for each part of the process. So it's genuine multi-threading, okay? Which is that's quite neat. You don't get that straight out the box. Nice little optimization, okay? Looking at the performance comparison using the between sequential and the pipeline. On 4GB, you don't no pipeline, 15 frames per second with a good CPU, right? With the pipeline, you can see the point. It's better, and we did actually get this machine up to 80 FPS with 4GB, by the way. So right now he's saying that, but that's crap. We can get there on 4GB with just the rest of what we're doing. God knows what will happen when I see. This is the thing. I have to prepare myself because the optimizations went so well for the small VRAM that I was like, actually, I should bait my expectation because, you know, when you get this much performance gains with a small amount, then maybe the trade-off is that doesn't scale. You see what I'm saying? Because it's too good to be true. There is no way that you're going to get it to go 4x on 4GB and then expect it to scale to 24 like that. It's not. Anyway, we'll find out. Usually what happens is you find a new bottleneck. So anyway, handling pipeline processing in active scenarios, memory errors. Yeah. So it's given us a bunch of troubleshooting. So this is where we get the GPU allocation percent. And the pipeline queue size, so you can make that bigger or smaller depending on how much oomph you got. But other than that, it's the same. Oh, and also the batch size. Batch size is still here. Okay. All right. So that was nice, and that cost me $4. So we're definitely up to $10 now. Probably more. But don't worry, we're going to go further. So that's that one. So we can now move on to the next area of improvement. Now, this one's fun. Vectorize operations that are currently using loops. That right there will make all of your stuff faster. Because this is something which is probably like not year one Python. You know what I mean? It's something more advanced. Basically, you learn to program it with loops, and you get really good at doing loops. And then they're like, right, forget everything you knew, because Python you can do vector operable. Anyway, you can do vectors. I'm not going to try and act like, because I've never used them. Like I said earlier, I'm an old school guy. Like that. The reason I say I'm old school is because I think in loops. You know, I was taught to program in those sorts of like Boolean logic, if statements, all this kind of stuff, right? And then you kind of convert that into whatever language you're trying to think about and design it. But Python uses vectors, which are faster than loops, and I'm not going to pretend like I know what they are because I've never written one. But I have now. So anyway, my clone has written vectors now for this. So anyway, pre-computed lookup tables, we mentioned that earlier. Faster alpha blending algorithms optimized for the GPU. So like I said, this is the plan. Okay, as we continue building the planner, more information is contained in the README. Once the changes have been made, we can test with the command I wanted to use, which includes the overlay config. Okay, and so for this phase, we're taking, again, each time I'm doing a new prompt, the last version was tested as working and uploaded to Git. So it doesn't matter if I smash it. You see what I mean? I can just go back if I smash it. But anyway, we did another $3 here. That's like $14 by now with the roundup. It's pretty cheap though, actually. And at the end of it, it works, right? So that gets us to the last one, which I think we already looked at. Yeah, this was the last one, so we opened up to this one. So here is the next area of improvement: FFmpeg direct integration. Replace FFmpeg Python wrapper with direct C API wrap binding. Use hardware acceleration, so NVEnc and NVDec. Zero copy data pass between FFmpeg and copy. Now, I think this is broken. This is the bit that I've spent $22 on to see if it'll get there. Because it's doing stuff that, frankly, I've never done. I've never done a zero copy path between FFmpeg and Koopy. What? So, I'm pushing my luck at this point, and I thought, I spent $14. I want to see what it can do, because this represented like a highly developed repo to me. And technically it still works because it falls back to the previous, working code in the project. But at this point it's starting to become unwieldy. If you have a look, we've done 10 million tokens, 5 million in the cache, and often it was going over 200k and dumping the window. So this is the point. This is where I realistically say this is the diminishing returns. This is the point where you're not really getting anything. You know what I mean? You're kind of pushing your luck now. And I think the way to actually fix this is to split up the files. So instead of having video panner and that's it, I would deliberately break up my architecture into lots of tinier scripts. Now, this isn't a bad idea, just generally speaking. But if you do it as a rule, to break up your scripts when they get over a certain length, and the reason is because you're blasting your context windows, guys, and eventually he's just going to be like, I can't do it, it's too long. That's what's going to happen. It doesn't even take long. But if you break it up, he can selectively ignore stuff you're not working on at the moment. You know what I mean? Oh, that module works, I don't need to remember that. I can just work on the stuff that I'm trying to fix right now. And then if you use that idea of externalized, you have a main.py and a bunch of modules, I can remember doing that with Gradio way back in the past. And you could have like separate tabs. Each tab in Gradio was a separate Python script, you know? Right. So anyway, let's have a look at the stuff that happened here, shall we? This is the big one, was it? Yeah, it's a big one. Okay. So it's going to use OpenCV. Oh, sorry. Currently, at the start of this project, we're saying OpenCV is being used for video reading and writing, NumPy and CuPy for image processing with CUDA when available, and there's an FFmpeg Python wrapper for the audio processing. Okay. FFmpeg integration is limited to add audio, which adds the original audio to the processed silent video at the end of the pipeline. So replace the Python wrapper with DirectC. So this is the thing I wanted to do. I wanted to use PyAV because, again, you can do more acceleration with it. Hardware acceleration for encoding, so we'd end up using NVENC and NDEC. Okay. And then the zero copy data path stuff, which is quite frankly black magic even to me. I'm just like, wait, what? Like I said, direct memory path. So there's no CPU GPU swap. It just goes straight from. This is crazy to me. I've never done anything like that before. So I was like, oh, this is really fun. And they say that you don't learn anything. I'm like, anyway. Is there a preference for which FFmpeg Python binding we should use? I think I was just like, no preference, NVIDIA, none. So I'm just like, look, I just want you to do it. This is a viability test. You see what I mean? And I think what we ended up having was problems with PyAV, and I'm not very familiar with that, to be honest. But anyway, I went ahead and did it. I think, did we immediately have problems? If you need to, I caught him trying to install things to system when we've got a VNV, and so I was like having to remind you. So yeah, and we reinstalled the VNV. I've run the VNV with success. Great, now you've done it, but there was a problem though. It works, but now CuPy doesn't work anymore. And so I think it was after we did the zero copy data path from FFmpeg to CuPy. And I think the problem is because my system is not got enough VRAM. So I can't. Do you know, it's really weird. I ended up developing software that I couldn't run on the machine that I was developing it on anymore. I was like, crap. I'll expect myself out by adding features that I can't even test. Like, crap. Okay. And then I think from about halfway down here, it starts to have problems. Yeah. So, FFmpeg Direct, there it is. He's like, oh, I've done it. And I think I'm like, it's broken. Yeah, here we go. See, that was where we started having the problems. Cannot import FFmpeg decoder, and the reason was because he'd started truncating things. So he'd have to go back and fix stuff where he got stuck and do it all again. And like I said, this is what happens when you do a big project. It eventually starts to go crazy, and that's why I break everything up. But like I said, at this point, I'm like, do you know what? Just go for it, mate. Just go for it. And I think I did get a stable version out of this at some point, but I can't remember at which point. It's kind of like I was like, this worked really well. Let's see how far it goes. You know what I mean? I wanted to know how deep the rabbit hole would lead, and as it turned out, 16 FPS with CPU. He's like, wow, I got you 1 FPS. That's a clear improvement. So crazy. Let's modify. Let's break it down. I'll add the helper. And I think this just now goes on now. Yeah, it just goes on. Oh, green text. Green text followed by an error. Yeah. Error checking, AV, no device. And so, like I said, I kind of put a limit on it. If he can't get himself out of a ditch within $10, which is way too much, by the way. It's only when I'm doing research, because I'll get data from what he fails on, see. So for me, it's like it's not so bad if he fails or if he wins. I get to find out why he's failing. But most of the time, I would say, listen, if you're spending like $5 and it's like broke, just start again. Just start again, because you can land it within $5. There's no need to spend $5 on fixing something, unless it's like really complicated, and then you should roll back and try again. At least roll back to your last stable version. Like I said, because it's very easy to just start digging and then no one will ever know where you went, you know. But what I was finding was that it was just the pure amount of data at this point, just the bloat, I guess, of the task, was leading to it, you know, significant loss of performance. You know what I mean? So, well, what do I know? You know, because the thing is, if you run this, it'll just say, "Oh, you don't have the system for it." No. So I got 3 options: the original implementation and the new one. So I go for the new one, and it crashes. And I'm not prepared to spend any more on it, because, like I said, it's saying, "Oh, you need to install AV," but I know it has it. So at this point, there's something else going on. I'm not prepared to find out. I would rather just start again. And like I said, I've already got 3 working versions that perform excellently. You could even argue that if you don't have big VRAM, a lot of these performance optimizations actually make it run slower. You know, if you have little VRAM, it'll run as fast as it runs. You can CUDA optimize, it'll run as fast as it runs. All the other stuff that we did made like 10 frames per second difference. So, like, you know, you can double the speed with the simple CUDA acceleration, and then you can get like 10% extra than that with all the other stuff. You know what I mean? So it's kind of like, is it really worth it? But then this is fine. This is like a fractal, it's a Fibonacci relationship. It's fine. That's fine. It's the diminishing returns, as I say. Not to say that batch won't help if we just increase the VRAM. See, parallelization of the job. And then there's multi-GPU as well. I don't generally do that. I focus on stuff for single GPU, because that's what most people are using, you know. Right. So which one is this? Yeah, so this is CLI. We're not looking at the unstable version here. This is just the CLI version, and also it's cooked. But yeah, so like I said, I wanted to do this for weeks, and I was like, how on earth am I going to show you my other machine? And we did it. So there it is. Like, for example, check this out. Here's a little bonus. How about this one? This is not to do with vibe coding. This is Writers Club's information right here. So let's just close all this quickly. So this was a prompt which I used when we were doing the writer's room stuff. So this one says, we can scan through the story pages to extract visual and descriptive information about the character, the emissary. And so this is at the end of book 2. And create a new document, Countess Amberley, which will describe visually in detail using information found in the story. So we're using our story to extract visual information from the book about the character. Okay? And as you view each page, once per response, update the CountessAmberley.md file with visual descriptions of the character grouped by outfit. For example, she may have formal, informal, and military operation attire, which should be recorded and defined in this file each time. And each time a new outfit is identified, it should be described and listed in detail. Please read the following pages in order, once per response, appending new outfits to the document. And then we go through we list every page, every chapter in the book. If these are too long to process, only look at a single page at a time, output your response, and then begin the same task with the next page. Got it? And this cost me 1 bunch of bananas, which is roughly 5. Okay, so I've successfully created the character description for Meredith Constance Amberley. Remember when we were spitballing the character design in the live? Formal diplomatic aristocratic attire, stealth infiltration, combat infiltration, cultural cognitive traits, operational protocols, authority, and her background and history. So as you can see, this is how I built up the character so that I had it more solid for book 3. And also, say I wanted to do a Countess Amberley model like I've done the Sharona model, yeah, then I've got a wealth of information. I've got a lore book about the world, and I've even got a whole book of information about the character that's distilled from the story we wrote. So it's all like a feedback loop where it all just feeds back into itself. What does she look like? It's written in the story. How do you describe her? With the image. It's just feeding back into itself. Okay. Let's see now. So we've looked at this. Smooth pan. What else do we have in there? Hermit, smooth pan, UV. I mean, I could show you UV before we segue into Sharona. So, as you can see, here's the UV stuff. I hope all the vibe coders don't run away when I start talking about writing stories. It's still vibe coding, basically. Right. But anyway, let's just run it. There's no need to mess about. I'm nearly done with this section now. It was the main focus of the show today, because like I said, I've got another machine which I plan to show off, and that one is not so heavily about one project. It'll be more fun about lots of different prompts, because my netbook is much more experimental, whereas this laptop is like this is my coding station, you know what I mean? Obviously I do a lot of it on the office, but this is more for making images and videos, and holy crap, some of the images I'm getting out of the latest model are insane. Hang on a minute, can I show this? Hold up. This is going to form a mini segue. Do I have Discord on here? Got to be careful with that, opening up Discord randomly on live. Quick, mute it. Blank it out. All the people sending me shit postings. There's too many of them. Stop it. It'll never stop. So yeah, check it out. That right there, Sharona V3, guys. We did it. Yeah, I know. Her shoes are super modern and she's got a leather belt. I know. The trouble is, all of these LLMs have got like a bias, and I decided to relax the lore because I remembered that we were trying to write a story based on imagery, not the other way around. Yeah? And there's nothing in the story that it doesn't say she doesn't have a belt. Like what, they can't make leather? That's a bit too crushing. So I'm going to be like, relax the lore a little bit, you know. She can have a belt and some shoes, it's okay. I'm alright with this. But as I said, this is a consistent character design now. There are still a few variations here and there, but nothing that you couldn't airbrush out if it really bothered you. So I'm happy that we can say from scratch, using key art, by creating a style model to create the character model, to use control nets and image photos and all different prompts with LLMs to ultimately curate a final character model, which is what you're looking at here. That is the output from the Sharona V3 character model. And like I said, we're going to look at all that in a minute. So, little teaser as we sort of blend our way back into the other stuff. The zebra does her haircut, right? Nah, she uses a coconut. Just cuts around it. Just take a coconut and cut it in half. Then you just cut around the coconut. Anyway. Yeah, we still need to do character art for the zebra. I'm kind of like, I'll just get control net of photos of zebras and use it as a layer, I guess. But yeah, so anyway, this is pretty simple, guys. We're just going to do ./start UV, and we're going to do .ps1 because we're in PowerShell. We're in PowerShell, so we're going to use .ps1. Okay, so off it goes. And this one is using the UV implementation. Now, I'm probably not going to let this complete because it is a full video, right? But as you can see, this machine should be achieving 15 FPS with all of the stuff we've done and the CUDA, blah, blah, blah. It's going to get up to about 65. Okay. Which is nice. It's like 5 minutes to 1 minute, you know. It's a very good speed up. So yeah, we'll cancel that. And like I said, the other CLI version, I actually thought UV was a little bit slower. I was sad to see that. Because it's the same code, but then it was about 5 to 10 frames per second slower. I don't know why, but it's the same code, so unless there's something wrong with the implementation, like I said, I'd rather blame myself when it's only 10 frames and just put it down to some kind of fluctuation, you know. But it's in the same ballpark. But I will continue. I won't be. I was thinking about it, but I'm not going to move over to UV. The main reason actually is because Claude doesn't know what the hell it is, which surprised me. So if I go into the UV docs, I had to give him all this stuff. Okay, let's just get rid of this for a minute. So I had to give him all this from the documentation section of the UV website. Yeah. I had to give him documents which explained dependencies, how to do dependencies, the startup guide, how to do project structure, how to do Python, how to run scripts, how to do PyTorch, right? I had to enter all that stuff in, and then it was able to rock, you know what I mean? It was able to rock and roll, but until that point, it didn't know what the hell it was, which kind of surprised me, you know? But ultimately, like I say, it was a fun experiment, and it did work, but it didn't offer any real performance gains, which I guess it shouldn't have, to be fair. It should have been about the same. And like I said, I just, you know, people say it's easier, but there are things about this which have a learning curve, and at that point, maybe it's not easier. You know what I mean? But yeah, anyway, like I said, I went back to the other version, so that's the point at which we switch. So you'll have to bear with me while I do a temporary coffee time. I'm just gonna crawl under the desk real quick, plug in. I should do an animation for crawling under the desk. Right. Okay. And we're back. Okay, we're back in the mothership. Laptop can calm down now. Don't worry, little one. You have done well. Boy, wake up. Right. So, Sharona. Oh, what could we do for book 2? Yeah, this is one thing I've been wondering about is book 2. Because book 1 was like a solo trip. She's migrating south because it's the winter. Or something, right? Look at that. That one's pretty good. See, like apart from this brooch that's always coming up on her shoulder, which obviously changes a lot, it's pretty damn consistent now. The character is consistent, the clothing is consistent, it's got a consistent art style as well. It's kind of strange It's kind of like illustration, but also a little bit photographic, kinda. So I was trying to go for like a Western graphic novel style. I mean, if you look at that there, you really do see it. But the character ended up being almost a bit too detailed. Like if you actually look, you can see it's not supposed to be a photo, right? And I think when you print this, it will convert quite well. That's a bit of a weird leg shape there. Don't know what's going on in this one, but you know, you can't have it all. Some are going to be better than others, I guess. Still got a few of the weird stuff going on. That's like a holdover. And also, see this feature here? This is in the depth maps. It's in the depth maps, but it's not in the model anymore. I took it out. So this is... every image in the dataset was removed when we trained that had this pattern in this area of the screen. So if you see that image in a depth map and it fills in well, that's pretty damn good, because actually it wasn't trained on that image. You know what I mean? Because I removed them all by hand. Obviously the depth maps are still there, so we're prompting with my depth map system, and currently we're using Sharona as the tag. Now there is actually something we can do there which is quite interesting, which is it's a whitelist system. Okay, so if I want her to be sitting, I can type sitting. When I had the tag there, that meant every image can run all the way through, right? We're now at image 689 on this test run as well. I started at 0 in increment, by the way. So we've done 680 odd images with Sharona as the filter, but now we're changing the whitelist to sitting. And so that means that only images that are tagged with sitting will actually be allowed in. So we've got to wait for this one to finish. Another good image as well. I like the style, man. That's starting to look top notch. Because remember, I want to illustrate a story where she's just walking around from place to place. We've got a bit of a weird thing there. It's not really sure if that's clothing or skin. That's okay. It's going to look weird in this one as well. It's because of the depth map. See, the depth map would have had something there, and it's designed there isn't actually anything there. That's annoying. But I meant the rest of it. The scene looks nice. It does look like a ruined After Earth type situation. So yeah, as you can see, look, I typed sitting. Now we're only going to get randomized but sequential sitting depth maps. And the depth map, remember, comes with the prompt. So the prompt will always match the depth. Now there's something which I never actually showed anybody, which is that at the moment, it's using the terms post-apocalyptic and dystopian a lot. Too much. So let's deal with that, shall we? What was the name of the thing? Was it Aborian? Somebody remind me what it was. It was something to do with Kona. Hyborian. I think I got there, guys. So let's just try and do this without destroying the world. So we get prompt swap. No, I think we can do both of them in one go, actually. So I'm going to use this just to edit what I want to do. So I'm going to put that like that. Comma. That. Okay. So I'm going to say post-apocalyptic thingamajigger. Take them out. Put that in there. So if you find that, I want you to do Hyborian, comma, space, barbarian. How about we say Hyborian age? Now this might not do much, but it will remove this post-apocalyptic dystopian trash that we're getting lumbered with. Yeah, anything but all this dirt and that everywhere. Like, I don't mind. It's Hyborian age, yeah? Yeah, that's what I got. Cheers, buddy. I did get there, but... Okay, so... Right, we put the output to the input, and then we get the output. Oh, there we go. There. Okay, so on the next one, now there are depth maps of satellite dishes, okay? They're part of the depth map, so like we're not getting anything randomly. Everything we're getting we asked for, yeah? Okay. So that will be a sitting image, which is post-apocalyptic and dystopian. So now I want to get Hyborian Barbarian. Let's see what it does. I bet it does something crazy. I better change the thing, actually. Just make a change. Like generally, if I make a change on a big run, just change the thing. Oh. 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 It looks the same. Hang on, did it work? Oh, this one didn't have that written in it? Ah, this prompt didn't actually have it written in it. Okay, hang on, next. It's not a bad prompt, I should have upscaled that. Ah, weird stuff going on here. Oh, it's Muad'Dib. This one also doesn't say dystopian in it. So some of the prompts don't even have that written in, and then what are you going to do? Desolate. Is desolate a keyword to get rid of the faces in the junk? No, the faces are actually coming in as a result of diffusion, doing the upscaling. And also, like, you know how you can see a tree which has like a smiley face in the bark? It's like one of those things. It learns to put faces in things. Like, see, look, see this feature here? I see this feature all over the place with the hole, with the thing, and it's just a random shape. And I think it's because it was a common rock shape in one of the early. It's like an infection of data. Also, mutation. So. So if I now say overgrown, that's going to give me, you know, an image from a random depth which is got overgrown in the tags. See, then we get one of these. And I could say desert or ice, or, you know, obviously you need to know what's in them. I think there's one with desert. Maybe. It'll soon throw an error if that doesn't exist. But yeah, it gives you unparalleled control over what you want to come out. Obviously, you know your images, right? But there it is. So yeah, like I said, this is going to work nicely. The first story should be quite easy to illustrate because it's just a journey. So as long as I can do the environments and the art style is consistent and the character looks like the character, which it should, I think we'll be okay. Also, of course, don't forget that you have like a full chain. So it's like some people will be creating stuff with AI and they have like some images of the character because they just made them, and that's the character. You can go, okay, so anyway, this character was created by curating this 600 image set that was created using this 1000 image set that was curated down, but also created using this 600 image set that was created by training this model and then curating that down, and then that model was trained by curating and captioning this other collection. You see what I mean? And so it's like you look at the You look at the amount of effort, the meticulous level of effort that's gone in there. Yeah, look, there's another one. There's also one there. Whoa, my plan is actually to outpaint, it's not outpaint, my plan would be to in-paint out any of the artifacts like that. Yeah, look, the upscaler made a face. It's my upscaler. It has a tendency to, it has an inherent restoration property. That's how it's making the face consistent. Well, consistent. Some more than others, right, guys? But yeah, basically, what this workflow using a depth prompt system into your depth control net using Flux Schnell on Q8, you end up with this system. It's quite nice. You get a lossy output, and then you take the lossy output into the upscaler, your choice. I use this one, your choice, and then you end up with your character at the end of it. And like I said, I'm targeting a graphical novel style here. And if you've been watching the stream for the last couple of days, you've seen this battle as it's played out. And many different models trained. So, you know, we have the safe model, the style, the character V2, the style V3, the character V3. So we start off here. One of the characters was photorealistic, was a cave girl. So we started off here, right? We then took it to a conceptual point with the combination with Midjourney, okay? But it was like all over the place. Every single outfit is different. Every outfit is different. We tried to nail that down, try to make it a bit more consistent, but we haven't even decided that she's got white hair yet, yeah? And then by here, we've curated down and retrained a couple times. So now the look is becoming more consistent, but the outfit design is still variating all over the place. And then we finally get to the style, the new style model. So the idea of this is to actually restyle new backgrounds and potentially new characters. For example, the zebra, right? So you'd swap out the woman for a zebra, use a control net of a zebra, and it should end up with this Laura making a zebra in the style of this project. Let's hope it's not orange. And then here's the final character model. Like I said, this is the one that we're testing. We're using the V9 right now. I actually think that either V8 or V10 is probably a little bit better, and I've kept the V6 as I often keep the early, just in case this is overtrained, yeah? Like, usually I go by V9, just as it goes, but I think that actually a V8 might be superior. So, for example, you never find it when you're in a rush. There. I had like seconds until it actually started the next one. It's also possible to blend the style model in with the character model. What's that? Can she paint the zebra orange to intimidate other animals? Well, I figure if humans were rare, they probably would dress in bright colours, because you are technically dangerous. You want to use fear in the jungle, right? Don't know. I figure, because, you know, and also, there's something about orange which a lot of people forget. Guess what orange is really good camouflage for? Sunset, sunrise. When's the best time to hunt? Dusk and dawn. So actually, it's really funny. It's like counterintuitive. The color orange is actually really good camouflage, but only in low light conditions, when you're being dazzled by the early morning or late night or, you know, evening sun. I was like, and that's the whole point, isn't it? You know, you approach them with the sun behind you and the wind, you know, Oh wow, she's got a black blouse for some reason. It's a bit random. Skip! But yeah, I was thinking maybe you do like it's just a standard zebra, but maybe she's got like an orange skin saddle, but it's not like a complex saddle. It would have to be like a, what does a Mongolian saddle look like? Do they even have them? I think they just ride bareback, dude. Mongolian, I'm going to look this up and look like an idiot. Saddle. Mongolian saddle. Nope, they didn't ride them bareback. They also do have saddles. Don't be silly. Probably turns out they invented it. 1600-year-old wooden saddle. The zebra will give up location. Well, I figured out that zebra is a bit like what's the name of the Lone Ranger? The Lone Ranger horse. Okay, so the Lone Ranger's horse, Silver, is the same meta as Silver Furnicar. So basically, when the character's doing stuff, the zebra just disappears. It may as well be in a pocket dimension, like in a video game, where whenever you need the horse, it just summons to your location, but it's like not even spawned in the game world most of the time. So obviously you can use the plot to explain this stuff away. Like you can say stuff like, oh, you know, the zebra just like goes away and trots around and does its thing until it's whistled at, you know, and then it comes running, or it's also always, yeah. So you can like play around. You can play around with the meta for this, but my idea is it's just like in Star Trek where they have a teleporter. The character needs a method of getting from A to B. It's the zebra. It's not supposed, like, it may be a plot point. Do you know what I mean? But it's like, you know, like a challenge she must overcome. Like she loses the zebra, but she's going to get it back. It's not supposed to be, you know. I did have a couple of funny ideas as well, but anyway, yeah, my idea was based on the memes of you know, horses that just kind of spawn in. Because you're right, the zebra would give up her location, but it could also be distraction or bait as well. Yeah, maybe it kicks. Yeah, maybe it's really fast. Maybe, you know what I mean? Because this other thing as well, you have a zebra, it's going to get attention. Maybe she's hunting the thing that's hunting the zebra, and that's just how they hunt. You know, there's lots of things you can do to play around with it. You know, zebra can just pretend to be drinking from the river or whatever, and then she's lying in wait. You know what I mean? And then it's tiger dinner again. You know what I mean? I'm just trying to play around with ideas here. But I do want to know. In fact, let's go Google Earth. This is something I do need to do. I wanted to do this on show. I keep forgetting. So for book 2, where's she going? She starts in Mongolia and goes south, right? So I thought, wouldn't it be cool? What are you talking about? Show me the ball. Right. Right, Mongolia. Mongolia! Oh wow, she's going to be going into ancient China, maybe. So the idea is that she's going south because it's winter, okay? So I'm guessing that she lives somewhere in these areas, somewhere around here-ish. I wish it could show you what it looks like in the winter. Can you do that? Have they got that yet? Time, historical time. I don't care about that. I don't care about that. Where, what, time? Oh, we can go back to 1980. I'm not going to say it. Okay, right, so anyway. Wait, what? That's completely different. What the hell? Wait a minute. Wait a minute. Why does it look so dry? What the hell? Wait a minute, what's going on here? Oh, it's just the contrast because it's high resolution. I bet they'll say, oh my goodness, all the trees are gone, but it's just the definition. The trees are still there. Okay, so if I go in here, Wow, look at this, guys. Maybe she's going to come across this. It looks like solar farm. Wait. No, that's not a solar farm. What am I looking at? Yeah, we're gonna zoom out from there and look at something else. I don't know what we just found. We just found something sketchy. Mongolia, please. Alright, so we're here. This is where the story is at. Cool. See, all you're trying to do is get some research down for a story, and you're like going into like weird black sites and stuff. Like, come on, guys. I don't believe it. So this is Mongolia. She's going south. So south, it looks like China. It's China, India, Myanmar. I mean, she could go to Inner Mongolia, Beijing. Or she could go through Tajikistan. So I don't think you'd want to go that way either, because you've got to go round the mountains, right? There's only two ways to go. And I think it would be easier to go... I think it'd be easier to end up in South Korea, guys. Like, if you started here... measure? Does it not do measure anymore? Marker. Yeah, local file, sure. So if you started there... Like, I'll admit, if you were going south, you're going this way, but the mountains kind of push you to Inner Mongolia, right? So if you ended up migrating across this mad... This is a desert, right? Whoa, okay. Maybe it's not a desert. Maybe it's tundra. Oh, wait. Oh. Okay, let's look at this bit. It's climate change, guys. That's where the climate change line ends. Please donate to fix it. Please donate. We will fix. So, yeah, I think she probably ends up having to go this way. Can we get like... Oh, wait a minute. Can we get like roads and stuff? Okay, exploration includes roads. I don't see any roads. Is that a road? It looks like a borderline. I don't think there are any roads out here. There's a road here, maybe. No, that's the boundary of a city. South from cold to normal. Yeah. From it's getting colder to it feels a bit warmer. Still cold, but not as cold. Look, this is like suspect, you know what I mean? I can't even see a river. Like, is there even, like, there could be a river that she has to walk down or follow or something, but... Okay, I got a better idea. Mongolian to Inner Mongolian routes. Land routes. There's the railway. Okay, where's that then? People's Republic of China. Yeah, basically, she ends up in China. I don't think you can really walk to Korea from the north, but this is like the far, 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 far future. Look, it looks like this. You know what I mean? Migratory routes. Follow the crane. Follow the crane, dude. There it is, guys. I've got my story element there. All she has to do is follow the cranes. If you're in southern Russia, northern Mongolia, guess what flies south? Cranes. It was so easy in the end. You follow the crane. Look, there's even multiple migrations to follow. So it's like, oh, you missed that one? Don't worry, you can catch the next one. So then you won't get lost in the... Because you remember the photo we looked at, right? The steppe is crazy. It's just big, flat, open space. There's no... You know, it's a... What do they call it? The steppe, as they say, right? The steppe. The steppe. Oh, no. Look, I just want to see the cool photo, guys. Look at that. No wonder they all rode horses. You know what I mean? But yeah, so there it is. There's the story element. So she's migrating, and how does she's going to get... Well, she can get lost, and then she can find a crane and follow it. And it'll be like in Noah's Ark when the dove comes. You know what I mean? Was it a land time forgot? There'll be no more countries concept. Yeah, there won't be countries anymore. This is set in the distant future after collapse of society, so there are no longer countries. This is why I'm looking for something with this. Look, the crane will outlast. So say humanity collapsed and all of our stuff is overgrown, and there's only like 1 million humans left on Earth because our population's been smashed. We've gone back to a simpler way of life, not quite tribal because everyone's paranoid as hell, right? But my point is, you end up with the hunter-gatherer setup again. Okay. So what can she use for navigation? She can't use a compass. She ain't got an iPhone. There's no GPS. There's no map. No one's literate. They can't. A lot of them can't even talk. So, but following a bird that always flies that way every year, man, it writes itself, doesn't it? Because we know about the patterns of migratory birds. These are cranes, the white crane or the eastern white crane or something. Yeah. Migration pattern of the eastern common crane from eastern Mongolia. So the joke is you can follow the crane. It'll take you right the way down to the South China Sea, just north of Beijing. Like some of them take you straight to Beijing and then to the sea. But that's probably because Beijing exists, I would have thought. These ones, look, most of them, they don't care where. In fact, they're avoiding people. They're avoiding Beijing, most of them. But some of them go through. So I wonder which one it is that goes through Beijing. CC209, green and blue, summer, wintering. So literally, you can use the crane, the flight you could follow, you could follow the birds. And as long as you travel at the right time of year, you'll see enough flocks of these things to not need to know the way. And then I guess as you get older and do it every year, you'd eventually know the way, right? But what I'm saying is, even if you didn't know the way, yeah, it's like taking the bus, yeah. Except you've got to follow it. But it's kind of like an arrow, isn't it? You know, like if you had GPS, you've got a little arrow on your phone, it tells you to go that way. Well, if all the birds are going that way in the sky, it's the same thing. It's the same thing, but you don't need batteries or satellites. So anyway, this is it. And like I said, I like to involve you guys. This is how I do my research. I know it might seem simple, but it's like you have an idea and you go, oh, where is she? She's in Mongolia. Let's look at it. Well, there's mountains there. And what I was thinking was the birds don't fly over the mountain, do they? So I don't need to know where the roads are. I don't need a railway. All I need is to know which way the birds go. And it turns out they all go roughly the same way. It's probably because this is the most efficient way to go south. You know, they've been doing it for a million years. You know, like probably they got good at it, right? But it also gives you an effective plot device which explains why she doesn't need a map. She does it the natural way. She doesn't even need to know the stars, you know what I mean? She doesn't even need to do like that kind of navigation. So yeah, it's quite interesting. But yeah, like I say, I like to involve it because this is the sort of thing I'll do. I'll like search around for stuff like this, and yeah, exactly, Fernica. And as Full Dive said, the stars are different in every season. People can predict the changing of season and the navigation. Yeah. Simpler time. The GPS arrow is resulting in following the bird. Yeah, that we even actually say as the crow flies, which means to go in a straight line from here to your destination, not by road, which is obviously a bunch of, you got to turn around and go around everything, right? So as the crow flies is a straight arrow. Yeah. But yeah, very interesting stuff. So that's my little writer's room spice for tonight. Let's see, how are we doing? Did it really just make that again? I feel like it made that a minute ago. The flowers are coming out nice. Her face, maybe not quite so much, but that's upscaled as well. I think some of them just come out better than others. And yeah, these ruins are actually looking interesting because it's like, what even was this? I want to give a bit of weirdness about the ruins. I don't want them all to look like the same boulder with a hole in it. But this, the enigmatic ruin, was it a pillar? Was it the foundation of a larger structure? Who knows? I'd like to leave it to the imagination. Okay. So let's see. What did we run out of time for? We did everything tonight. Can you imagine it? That's insane. So anyway, we did everything, guys. So yeah, tomorrow we'll be back. I'm going to be publishing these lauras. Don't forget, we put the narrative buckets up on the repo so you can use them. We will be releasing some of these style models, but at the moment it's still a work in progress. So I'll probably be releasing like all of the early stuff. I want to make a Sharona project and put all the versions in one place. That's the idea anyway. Because the idea is we've got lauras out for generating images for Westwick, Empire, Outpost. We don't have a Laura for Tower yet. So maybe tomorrow we start doing some initial conceptual stuff on the Tower series, because that's the satirical wizarding adventurers narrative bucket. So yeah, that's what I'm thinking. Tomorrow we start the process of building that as well, because this is nearly finished, right? I'm confident this is going to be able to illustrate this story. There's 2 more books to write in the Sharona series. Yeah. So that's about it, guys. Thank you for watching. Thank you very much. We'll be back same time, same place. See you tomorrow.